systems reason. You are given the following system of equation: y is equal x squared and y is equal minus 1. Without graphing or performing any substitution, can you see how many solutions this system must have? Describe your reasoning. As we see here, when we are equating, for example, x squared is equal with minus 1, we are going to get an imaginary number. So x is going to be equal, if we are want to find the solution, is going to be imaginary. It's going to be I, and x is going to be minus I. So those are two solutions, but those are imaginary solution. Because those are imaginary solution, it means we do not have a real solution. But here, how can you see how many solution? It's for real solution. So just let me write here for real solution, or an R. So it means a real solution. There are no real solution. The system doesn't have any real solution, so it's a zero real solution. And here it says construct argument. Can a system of equation with one linear and one quadratic equation have more than two solutions? It cannot have more than two solutions, because whenever we have one y is going to be one x is going to be quadratic equation. Let's say ax squared plus bx plus c plus bx plus c. And the other equation is going to be the linear equation. Let's say this is a mx plus k. Let's say plus k, because I just want to take a different constant. If we combine y equal with y and we want to find the solution here, what kind of the equation is going to be? This kind of the equation is going to be quadratic equation. And quadratic equation is the number of the degree here. It tells us the most solution that a quadratic equation can have two solution. At the most two real solution, one real solution, or zero solutions. Therefore, it cannot have more than two solutions. But if we want graphically, for example, to find out, so graphically, let's say we have in the Desmos, and we have here, let's say a parent function. I took a y is equal with x squared, and any quadratic function is upward or downward. So now if we take, for example, a linear equation function, let's say y is equal with x, and if we are looking here graphically, whenever we are moving the graph of the function y is equal with x, is going to intercept just in one place. So this one tells us if we have, for example, x is equal with a number. This is not a function, this is just equation. If we can just drag, you see it has just one solution. Whenever we go, it has just one solution if y is equal with x squared. But for example, if we have equation x squared plus y squared is equal with 5, so we have a circle, but and the other one is equation x is equal with a constant. It means it's going to intersect in two places, but not more than two places. And let's say y is equal with a constant. You see, it has no solution. This tells us no solution. No solution when they do not intersect at all with each other. Then it has one solution here. When y is a function and is a constant, for example, we have no solution, one solution, and at most, whenever we drag this function y is equal with a constant and it goes toward the infinity, it's going to intersect the graph of the function just into places. And for example, if this y is equal minus x squared, it's going to go in downward as in the lower position. But here I wrote it just in one case. So now let's say y is equal with x. Let me take this out. And this I cannot rotate with the Desmos. In any position, if for example here I'm fixing a point, and if I am moving, you see here is in a 2 points. Whenever I am moving, is going 2 points, and if I'm moving too far in this side, for example, here I'm fixing this point, and let's say point 0 if I'm fixing, and point 1 if I am moving around, is going everywhere to at most to intersect in two positions with the two places, two intersections. So graphically and analytically we can show the function the equation with one linear and one quadratic equation do not have more than two solutions. It has those are two arguments that we are presenting here. The most solutions that they can have is two solutions.